Hi everyone, so in our last video we talked about the rules and the process of negating statements that have nested quantifiers, and as promised in this video we're going to go through a little bit of a challenging practice problem that has to do with nested quantifiers and negating that statement. Okay, so here's our practice problem. Let's read it firstly in order to get an idea of what's going on here. Well, the statement says, there exists a real number a, such that a is greater than 0, strictly greater than 0, and for all real numbers x, if x is greater than or equal to a, then 2 to the negative x will be strictly less than 1 over 100. So right off the bat, this is quite a mouthful, and immediately we can't decide whether this is true or false. We need to sort of more carefully decompose this and get a feel of what's going on and what needs to happen in order for this to be true. So let's do that. Let's think about what needs to happen here in order for this statement to be true. Well, because we have this existential quantifier from the beginning, we know that for this statement to be true, we just need to find one choice of a for which this works. So we just need to find one choice of the variable a for which this applies. So there's a domain for our variable a. It has to be a real number, and it also has to be strictly greater than 0. In other words, it's a positive real number. So we know that a is a positive real number, and we want to find a choice of a for which, for all real numbers x, this implication is true, which is that if x is greater than or equal to a, then 2 to the negative x is strictly less than 1 over 100. Well, let's think about this. So if I choose any choice of a, we know that a is going to be positive, right? And now let's think about what needs to happen in order for this implication to be true. Well, in order for this implication to be true, then this first part here will be true. Well, if x is greater than or equal to a, well, since a is positive, then x is also strictly greater than 0, right? Well, if x is strictly greater than 0, then 2 to the negative x we can write as 1 over 2 to the x, where x is some positive real number. And now we want 2 to the negative x, which is 1 over 2 to the x, to be strictly less than 1 over 100. Well, if we want this to be strictly less than 1 over 100, another way of thinking about that is that we want 2 to the x to be greater than 100. Because if I have a denominator here which is greater than 100, well then this entire fraction will most definitely be strictly less than 1 over 100. So let's write that down. This implies that 2 to the x is greater than 100. Well, now let's think about which x can give us this result. Well, right off the top of our heads, we know that there's actually quite a few x's which can give us this result. In fact, let's think about x equals 100. Well, if x equals 100, then 2 to the x, which is equal to 2 to the 100, will be greater than 100. And what this implies is that 1 over 2 to the x will be strictly less than 100. So this actually gives us the result that we want. But this is we only showed this for x equals 100. What about if x is greater than 100? Well, if x is greater than 100, then this 2 to the x will only keep getting bigger. So it'll only keep getting smaller than 1 over 100. Well, actually, what if we make our choice of a to be 100? Let's choose a to be equal to 100. Does this fit the domain of a? Well, it seems to, right? Because a needs to be a real number, and it also needs to be strictly greater than 0, and 100 most definitely fits those two requirements. So we can choose a to be 100. Well, if we choose a to be 100, then does this work? Let's think about it. For all real numbers x, If x is greater than or equal to a, well, now we have a value of a, so we can think about this as if x is greater than or equal to 100, then 2 to the negative x will be strictly less than 1 over 100. Well, if a is 100 and x is greater than or equal to a, then 2 to the negative x, which is 1 over 2 to the x, will most definitely be less than or equal to 1 over 2 to the 100, because 2 to the x will be greater than or equal to 2 to the 100. So 1 over 2 to the x will be less than or equal to 1 over 2 to the 100, but 1 over 2 to the 100 is most definitely less than 1 over 100. So this tells us that 1 over 2 to the x will be less than 1 over 100. For no matter which x we choose, if it's greater than or equal to 100. Well, this is perfect because this shows us that our statement is actually true. We chose a positive real number a for which this works, right? We chose a is equal to 100. And if a is equal to 100, first of all, it fits our domain. As we talked about, it's a positive real. And second of all, no matter which real number we choose, this will be the case, right? If x is greater than or equal to a, in this case meaning if x is greater than or equal to 100, then 2 to the negative x will most definitely be strictly less than 1 over 100. So this is actually a true statement. Well, if the statement is true, which we showed with our scratch work here, then the negation must be false, right? So now let's negate this statement. Let's be very careful while we're negating this statement, and let's see intuitively if we can justify to ourselves that this negation is actually false. Okay, so now I've copied this original statement onto a page so that we can read it while we're negating it from left to right. So right away, we have this existential quantifier here. There exists a real number a. That will turn into for all real numbers a. And now we have this part here such that a is strictly greater than 0. However, we want to remember from our first video of negating quantifiers that when we negate any quantifiers or any mathematical statements, the domains remain. So here we have our variable a, and in our original statement, it tells us what the domain of a is, right? It tells us that a is a real number and a is also strictly greater than 0. And this domain must remain in the negation as well. So we don't want to negate the domain. We don't want to change the domain. So actually, this part here will not change in our negation because it tells us the domain of a, of our variable. So this will remain such that a is strictly greater than 0. Okay, and now moving on, we have this universal quantifier here, which we do negate and we turn it into the existential. So this turns into there exists a real number x. So now we have, reading from left to right, we have for all real numbers a such that a is strictly greater than 0, there exists a real number x. And now we have this predicate here that we need to negate. And if we notice, this predicate is of the form if then, right? It's an if P then Q statement. Or in other words, P implies Q. Well, we want to remember and be very careful about negating implications like this. And here's a reminder down here of how we negate those implications. The negation of P implies Q is P and not Q. We want to make sure we're not doing something like negating P implies Q by turning it into something like not P implies not Q, right? This is not correct. This is the correct negation of implications. So let's think about what is P and what is Q here. Well, I have my first part here. That's P if x is greater than or equal to a. And then I have my implies here, in other words, then, and then I have this as my Q. So I'll label these P and Q. Well, If we look back, the negation of P implies Q is P and not Q. So how can we negate this predicate? Well, we have P, which in this case is X is greater than or equal to A. And then we would have and not Q. In this case, Q is 2 to the negative X is less than, strictly less than 1 over 100. The negation of that would be 2 to the negative X. Instead of strictly less than, it would be greater than or equal to 1 over 100. Okay, so we have this negation now. Let's read it again from left to right to sort of understand what our negation is now telling us. It says, for all real numbers A, such that A is strictly greater than 0. In other words, for all positive real numbers A, there exists a real number X, such that X is greater than or equal to A, and 2 to the negative X is greater than or equal to 1 over 100. Well, let's think about this. Well, this has to work for any positive real number A, right? Because I have this universal quantifier here, so this has to work for all choices of A in our domain, which is the positive real numbers. Well, if I choose any positive real number A, in order for this to be true, there must exist a real number X such that these two things apply. Well, for any choice of a positive real number A, I definitely can find a real number X such that X is greater than or equal to A, right? I can simply just choose X is equal to A plus 1, and that gives me X is greater than or equal to A. But we're not quite sure if we can find an X that will always make this true, right? Because we want to think about this again. X is definitely going to be positive, right? If this is true, if X is greater than or equal to A and A is positive, well then X is definitely positive as well. So again, in order for this to be true, we know that 2 to the negative X is equal to 1 over 2 to the X, where X is some positive real number. Well, we want to think about when is 1 over 2 to the X greater than or equal to 100? Well, 1 over 2 to the X is greater than or equal to 100 when 2 to the X is less than or equal to 100, right? We need 2 to the X to be less than or equal to 100 in order for this entire fraction to be greater than or equal to 1 over 100. Well, 2 to the X is only less than or equal to 100 for a limited number of choices of X, right? If we get over some number, like we saw for 100 in our last example, well then this won't be the case, right? If we have X is equal to 100, then 1 over 2 to the X will most definitely not be greater than or equal to 1 over 100. But then this doesn't seem to work, right? Because this has to work for all choices of A. But if I choose A to be 100, like I chose in the last example, well then there doesn't seem to be any X greater than A that will give me this result. Because any X that I choose greater than 100 will give me a result of 2 to the negative X is strictly less than 1 over 100. So there doesn't seem to be an X real number that works, that makes this true if A is 100. And if it doesn't work for A equals 100, it's immediately not true because this has to work for all choices of A in the domain in order for this negation to be true. But this is great, right? Because we showed that the original statement was true. And so if the original statement was true, the negation should be false. So this is sort of a sanity check telling us that we definitely negated this correctly because we got the truth value that we were expecting. Okay, so this was an example of a more challenging practice problem to do with nested quantifiers, and we were able to prove it with our scratch work and to negate it properly. I'll see you in the next video.